So why don't we spend a little bit of time working on our console and using the PS command so we can start looking at our process status. So as if by magic, I'm now on the console of my server machine, and we can see I've logged on as a standard user. For seeing the process status, there's no real need for me to be logged on as root. Only if I want to manage those processes or processes belonging to other users than myself would I need to be logged on as the root user. So for the purpose of this demonstration, we can stay logged on as the standard user. We're going to be looking at the PS command mainly here, and we can see when I run just the PS command without any of the options, I get to see the process ID, so the number that uniquely identifies this process, the TTY to which it's attached, and some processes are not attached to TTYs. We can see then the CPU time, so that's the time column is representing the CPU utilization, and then the actual command that we're running. Now, of course, if I want to see more, I can start applying options, but this is where it gets a little bit awkward with PS, is that the fact that we can take 3 styles of options, not just one. We can see this more clearly if I look at the man page, and it's never a bad thing to go in and take a look at the manual page, is it? So this is going to open up then the man page section 1, user commands for the PS command. Now it's the middle area of the page that I'm really interested in, and look at it, this version of PS accepts several kinds of options. Unix options, so they are then grouped together with a single dash. We get the BSD options, which can be grouped together but must not be used with a dash. And then the GNU long options, which are all preceded by 2 dashes. So of course this makes it a little bit awkward, but let's just take a look to dispel any of these myths of how difficult it's going to be. We probably only need to use one style of switches most of the time, and you're going to stick to that. If I look at, say, PS-E, this will show me all processes. And this is, of course, then just using the Unix style. I can get something similar where if I go through and look at all processes with the A, and we can say both the user processes and processes not assigned to terminals, then I can see something similar with PSAUX. I'm getting a longer listing here, so I'm getting more details in the columns that are coming back. But let me just do a Control L to clear out of that. If I wanted to see some of the GNU long options, one thing that I could do, something like this, if I do a PS and -E, and I can mix options together and then put the forest option here, we get kind of a process tree showing. It's really significant when I look down then towards the bottom of the page. We can see then the SSH daemon and the child processes. I'm connecting via SSHD, and we can see my bash shell and the PS command that I've just executed. So we're grouping all of our processes together in their process hierarchy. Having said that, if I really want to look at the process tree, the easiest way to do that is with the command pstree, and we'll probably get then an easier output. So we can see then that process ID 1 on this system is systemd, and then all our other processes are spawned from that. Let's just clear the screen out. Running the PS command without any options just shows within my current shell, but we can work with this and get a full listing. When we look at the full listing, we get to see the user ID who's running the process. We get to see the process ID and the parent process ID. We can see when it started. So look at the bash shell there. It's the 13th today, and somebody left themselves logged on overnight. I wonder who that was. Tut, tut, shouldn't be doing that, should I? But we can start seeing then a little bit about the process, getting a bit more information. But as well as the full, do you know what? We've got extra full as well, minus capital F. Now when we look at the output, we start getting some additional information coming back. We get to see the size of the program. Well, what's important is the resident set size, so how much memory is actually being used at the moment. So we can start getting more information coming back. And again, we can always go through and examine the man pages if we do need details on all of these columns. But we're not stopped there. Let's just clear out. We can actually do a PS minus L for a long listing. So we have a full listing and we have a long listing. Here in the long listing, then we can start seeing instead of the username, I get the user ID. We get the priority of the process and the nice value, and we'll be looking at that in another module that follows this module. So looking at how we can control the priority of an application. If I want to, I can use minus L and Y, and that will replace the address column with the resident set size, so how much memory is being used. If I control L again, we can jump out of this. Very often, if we want to see all of our processes, what people will do is either the PS AUX, if you're used to that, and then go through and maybe look at PS minus ELF. So we get a long listing and a full listing. If you were searching for a particular process, then what we might do is then go through and pipe this information through to grep. And let's go through and look for SSHD. And we can see then, don't be worried about that last entry because that's my actual search that we're we're carrying out. But we can then see all of the processes related to SSHD. So we might want to go in and look at the resources that are being used by SSH, or we might want to go through and tidy up these processes, send signals to them, or whatever. But we can start getting an idea now of what's running on our system by taking a look at the PS command and seeing the processes that are in use and a little bit of the resources that they are taking up. Now with this done, let's go through and take a look at how we can use the proc directory and the $$ variable.